Okay, good afternoon class. So today we're looking at probability. Okay? I think there's the easiest section of work in grade 12. It's chapter 10 from the Mind Action series. Okay, so the fundamental counting principle. Now in grade 11, we have done probability. We've done the Venn diagram. We've done the two-way contingency table, the two-way table. And we did the tree diagram. Okay, so that still stands. Okay, and then we add this the fundamental counting principle to that. Okay, it's worth 15 marks in total out of paper 1. Okay, so it's 10%. Okay, that 15 marks is basically split between the grade 11 and 12 probability. So we are told that consider the situation where you flip a coin and then roll a die. There are 12 possible outcomes in the situation. You can get the heads 1, 2, 3, 4, 5 and 6 and tails 1, 2, 3, 4, 5 and 6. For the coin there's only 2 possible outcomes, whereas for the die there are 6 possible outcomes. Thereafter we can state that there are a total of 2 times 6, which is 12 total possible outcomes. This shortcut approach, this here, where we actually just say 2 times 6 is 12, that is the fundamental, what we call the fundamental counting principle. Okay, you guys understand? So, they got the rules. The first rule is rule 1. You guys can write this down. We are told that if one operation can be done in m ways, and the second operation can be done in n ways, then the total possible number of different ways in which the operation can be done is m times n. Okay, so pause the video at this point. Right, so let's look at example 1. Example 1 is on page 308. So here we are told a meal can be arranged, a meal can be made. You see I'm talking about food now, I get confused. A meal can be made up as follows. Choice 1, fish, meat or chicken. Choice 2, mashed chips, baked potato, rice or vegetables. Okay, now this is not our kind of people, no? We would have in our plate meat and chicken, chips and the rice and veggies, no? That's our meal. Okay, but this is a different breed here. So, let's say that they're only going to use one of the 2 choices. So what I introduce is, the question is how many different meals can be made up using these choices. So what I do is, I take an easy approach to it. I say, okay, since there's 2 choices, I use 2 bids. Okay. So this is choice 1, and this is choice 2. How many options do I have for choice 1? Fish, meat, chicken. You have 3. How many options do I have for choice 2? 1, 2, 3, 4, 5. And 3 times 5 is? There's 15 options or 15 ways. You understand? Let's count it. If it was fish, start meat. Meat mash, meat chips, meat baked potato, meat rice, meat vegetables. So it's 5. Fish. Fish mash, fish chips, fish baked potato, fish rice, fish vegetables. 10. Chicken. Chicken mash, chicken chips, chicken baked potato, chicken rice, chicken vegetables. How many you get? 15 in total. You guys understand? Imagine there was another option here. It would be 6. It would have been 18. If there was another option, it would be 7, which is 21. So the more options there are, the bigger the ways or different meals can be made up. You guys understand? So the idea is not to write it all out, to count it out. The idea is to have a shortcut. And as we indicated initially, that shortcut is called the fundamental counting principle. Okay? You guys understand? Okay, we'll do example 2 now. Alright. So we're looking at example 2. Example 2 is on page. Sorry? What? Same page. You guys open your mouths. Right. A gift pack can be made up as follows. Choice 1. The Valentine's now. No? People, choice 1. We have a choice of a CD out of a parcel, 4 different CDs. You guys know what the CD is? Yes. So there's 1 CD of 4 different CDs. Choice 2. Choose 1 packet of chips out of possible 5 different chips. Choice 3. Choose 1 chocolate type out of a possible 12 different types. Choice 4. Choose 1 type of fruit out of possible 3 different fruit types. How many different gift packs can be made? So how many bids would I draw now? 4. Why? Because there's 4 choices. How many options do I have for choice 1? 4. How many options do I have for choice 2? 5. Choice 3? 12. Choice 4?
Your attention please. 8C, can you please report to the book room now? 8C to the book room. Taylor Rudolph, can you report to the office for a collection?
Okay. Any confusion at this point? Okay. Can I move on? Yes. Okay. Easy enough? So far. Example 3. Example 3 is on page 09. See how clearly you speak now that they're building. Alright. Consider the word park town. You are required to form different 8-letter word arrangements using the letters from the word park town. An example of the word arrangement would be A, P, K, R. I'm not going to try and say that word. This arrangement of the letters need not make any sense. So it doesn't need to actually make another word. Okay, so this is the arrangement here. How many possible word arrangements can be made if, in the first case, the letters may be repeated? So if the letters may be repeated, how many letters are here? There are 8 letters. Can you see that? So how many bids would I draw here? 8. No? 1, 2, 3, 4, 5, 6, 7, 8. The letters may be repeated. So how many options do I have here? Of these 8 letters, how many letters can I choose from? Those letters in that word. 8. And the second word, letter? 8. This next letter? 8. 8. 8. 8. There's 1, 2, 3, 4, 5, 6, 7, 8. So if I multiply this will simply be 8 to the exponent. You all understand? So any confusion? So the answer is 16,777,216. So now let's look at B. B says the letters may not be repeated. How many bids do I have now? Still 8 years. But how many options do I have on the first bid? How many of these letters can I choose from? 8. Not so. Now say for argument's sake, I chose W on the first. Then how many options do I have for the next bid? 7. Now if you chose A on the second, what would I have for the third? 6. Then 5. Then 4. 3, 2, 1. Which is simply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Give you an answer of 40,300. Is there any confusion? Last question. Example 4. The example 4 is on page? Same page. Okay. So here, we are told how many different ways are there to predict the result of 5 matches, where each match can either be a win, loss or draw. So how many bids do I throw here? There's five rugby matches. There's 5 bids. So how many options do I have on the first game? 3. It's win, loss or draw. Second game? 3. Win, loss or draw. Win, lose or draw. Win, lose, and so on. So in other words, that would simply be 3 to the exponent 5. 3 to the exponent 5 gives us 240. Right, you guys understand? Yes. People, for homework, it's exercise 1 on page 310. People, enjoy the rest of your day. Good afternoon, class.